Welcome back to the Deep Dive, where we plunge into the background stories of the global economy, the companies and technologies that run your world, but often stay just out of sight.
And today we are definitely pulling one of those companies into the spotlight.
We really are. We're talking about a truly invisible giant, Corning Incorporated.
You know, when most people hear that name, Corning, their minds probably drift to Pyrex measuring cups.
Oh, absolutely. Or maybe those opaque white casserole dishes that, your parents or grandparents had.
Exactly. They were everywhere. But that familiarity, it's actually a bit of a historical red herring.
A huge one.
We're talking about a 174-year-old multinational technology powerhouse
Yeah.
that is responsible for fundamental components in everything.
From the deepest space telescopes to the fiber optic cables speeding data to your home?
And yes, the screen that you might be holding in your hand right this second.
Absolutely. So our mission today is pretty straightforward. We're tracing the stunning evolution of this organization, which was founded way back in 1851.
And we're going to analyze its transformation from, a traditional glass maker to this industrial titan that specializes in advanced optics, ceramics, and specialty glass.
And we want to show you how a strategy based on disruptive innovation and, maybe more interestingly, how surviving massive, expensive failures paved the way for today's essential technologies.
The lineage is just remarkable. It started as the Bay State Glass Co. in 1851.
Right.
Then it became Corning Glass Works, which is the name most people might recognize, until 1989.
And now?
Now it trades as GLW on the NYSE. It's a proud S&P 500 component, and look, it's recognized globally as one of the world's biggest and most critical glass makers.
But the real hook here, the central aha moment for you, the listener, is this. How exactly did the company famous for kitchenware become the exclusive supplier of Gorilla Glass, the screen on your iPhone?
That is the ultimate question of corporate reinvention, isn't it?
It really is. And the key to understanding that radical pivot lies in a single, decisive, strategic move.
In 1998.
Exactly. In 1998, when they divested all of their consumer lines, Pyrex, Corningware, Corel, to focus purely on industrial and scientific applications.
They just cut ties. With nearly a century of highly visible brand identity.
It seems almost crazy.
It was a bold, almost ruthless, strategic amputation. I mean, think about it. They looked at the brand equity they had built, the kitchenware that defined American home life for generations, and just decided it wasn't their future.
Why, though?
They decided those products simply weren't leveraging their core strength, which was, and still is, proprietary material science.
And that one move defined their entire current scope.
Absolutely. Corning now operates across 5 incredibly demanding high-technology sectors: display technologies, telecommunications, environmental tech, specialty materials, and life sciences.
And crucially, this wasn't just a random diversification. This focus has been driven by a philosophy they cemented after World War II.
Right. It was about aggressively pursuing disruptive and on-demand product innovation.
Constantly fueled by extensive, focused R&D spending. They chased technological necessity, not just consumer trends. And that commitment to R&D is something we'll see repeated throughout their entire history.
It's a foundational commitment. It's in their DNA. So I think we should start where it all began, the nomadic origins of this company.
Okay, let's unpack this journey. It starts with the founder, Amory Houghton. And in the 19th century, glassmaking was heavily dependent on your location.
Completely. You needed to be close to raw materials, and you needed fuel sources. So the company was literally looking for the right place to put down roots.
It didn't start in Corning, New York.
Oh, not at all. The company started life in 1851 in Somerville, Massachusetts. It was called the Bay State Glass Co., founded by Amory Houghton Sr.
But Massachusetts didn't hold them for long?
Nope. They made a big jump next, landing in the emerging industrial landscape of New York City.
To Brooklyn.
That's right. The company moved to Williamsburg, Brooklyn, where they operated as the Brooklyn Flint Glass Works. This was a critical step, but they were still searching for a long-term, stable environment.
So it wasn't until 1868 that they finally found their permanent home.
It was. Under the leadership of Amory Houghton Jr., the company relocated to and settled in Corning, New York. That's what gave the company its final name and its permanent headquarters.
So why Corning, New York? What made that location finally the right fit?
It was all about logistics and energy. Corning had great access to rail lines, which was critical for transporting both raw materials in and finished glass products out,
And the fuel.
and natural gas, which was essential for firing their furnaces consistently. The move really solidified their identity, tying the company physically and culturally to that town forever.
It's fascinating how quickly they recognized that geographical stability needed to be paired with intellectual stability. They set up a formal research backbone incredibly early.
Decades ahead of the curve. We tend to associate these big industrial research labs with, Bell Labs or Xerox PRC in the mid-20th century.
Right.
But Corning was way ahead of that. They established one of the first industrial research labs in the United States right there in Corning, New York in 1908.
And this wasn't just for quality control, was it?
Not at all. This was a dedicated allocation of resources to pure scientific discovery right inside the company structure. This decision to invest systematically in chemistry and physics, not just perfecting existing manufacturing techniques, was absolutely foundational.
I mean, you can draw a straight line from that decision in 1908 to today.
You really can. Without that 1908 commitment, there is no fiber optic cable, and there is certainly no Gorilla Glass.
So let's look at the foundational products that came out of that R&D commitment before World War II. The first major industrial application that really cemented their importance globally was illumination.
Precisely. Early on, Corning didn't invent the light bulb itself, but they invented the process for making the glass envelopes, the bulbs themselves, cheaply and at a massive scale.
Which is really the key to commercialization, isn't it?
It's everything. They supplied the glass for Thomas Edison's original light bulb, and this partnership was sustained. After the 1892 merger that created General Electric, Corning remained a core glass supplier for GE's massive, growing lighting division.
That's a powerful early partnership, defining them as a high-volume industrial supplier. But the next product launch is the one that every single listener probably knows.
Oh, yeah.
Even if they don't connect it to the modern industrial giant we're talking about today.
The kitchen revolution, brought to you by Pyrex.
Exactly.
The Pyrex launch in 1915 was a total game changer for the American consumer, and it was a byproduct of material science they developed for something completely different.
What was that?
Railway lantern lenses. Those lenses needed to withstand really rapid temperature shifts, like a hot lantern being splashed by cold rain without cracking.
And that's where the special glass formula came from.
That's it. That core borosilicate glass formula, with its incredibly low coefficient of thermal expansion, was adapted for the kitchen.
So if I understand the science here, standard glass shatters when it heats unevenly because one part expands faster than another, causing stress.
You nailed it.
But borosilicate glass, like Pyrex, it resists that expansion almost entirely.
Right. Pyrex holds the distinction of being the first ever consumer cooking product made with temperature-resistant glass. It allowed people to move food directly from the oven to the refrigerator, which revolutionized food prep, storage, and cleaning.
Yeah.
It basically democratized heat-safe cooking.
It's incredible. So you go from the revolutionary kitchen counter to the deepest reaches of the cosmos. The Corning trajectory just keeps expanding.
It really does.
The Palomar Observatory mirror casting project, fabricated between 1934 and 1936, remains an unbelievable feat of engineering.
This project just goes to show you the company's willingness to tackle challenges that others deemed impossible. George Ellery Hale from the California Institute of Technology approached them with a task.
To build a massive telescope mirror?
A massive 200-inch or 5.1-meter telescope mirror. And it wasn't just the size, it was the material requirement. Low expansion borosilicate glass.
So why was that low expansion part so critical for a massive telescope mirror?
Thermal stability is everything in high-resolution optics. I mean, everything. If the mirror surface slightly changes shape, even by a tiny fraction of a millimeter due to temperature fluctuations over the course of a night, the star image will blur into nothing.
So a 200-inch mirror made of standard glass would be totally useless.
It would warp catastrophically. The only way to ensure perfect optical fidelity was to use borosilicate glass, which barely changes shape with temperature swings. They were attempting to achieve optical perfection on a monumental scale.
And the casting process itself was fraught with difficulty. I understand they failed on the first attempt, which tells you just how steep that learning curve was.
It was a very high-stakes failure. Corning's first attempt resulted in a cast blank with voids and structural imperfections.
So they had to scrap it.
They had to scrap that massive piece of glass. But, true to their R&D culture, they used the lessons learned. The cooling rates, the furnace operation, the material flow, to inform the second attempt.
And even after the successful second casting, the logistics were just staggering. It wasn't like, baking a cake.
Oh, far from it. That massive 200-inch blank couldn't just be pulled out of the furnace. It had to cool incredibly slowly and carefully to prevent internal stresses from shattering it.
How slowly?
The cooling process for that single piece of glass took a full year.
A whole year,
A
wow.
whole year. And during that year, while it was delicately sitting in its annealing oven, the whole facility in Corning, New York, was almost lost to a devastating flood.
You're kidding.
Yeah.
The idea that a technological marvel, which took a year to cool, was threatened by a natural disaster is just an incredible anecdote.
It really highlights the vulnerability of these large-scale scientific undertakings.
And for those interested in the archaeology of technology, that failed first blank still exists.
It does. It now resides in the Corning Museum of Glass, a physical monument to a scientific attempt that provided the necessary knowledge for the eventual success.
It's a perfect symbol of their commitment, isn't it? Failures aren't just discarded, they are artifacts of learning.
Exactly. And before we move into the post-war era, we should briefly mention the 1935 partnership with Owens, Illinois. This collaboration led to the formation of Owens Corning.
Which became its own giant.
It did. It spun off in 1938 and became a leader in building materials and fiberglass. It just shows Corning's early, broad involvement in material science that extended far beyond traditional lighting or consumer goods.
So by the 1940s, Corning was established as a master of precision glass fabrication, a reliable supplier to giants like GE, and a consumer icon with Pyrex. The next few decades, however, would be defined by the high-stakes, internal R&D projects that changed absolutely everything.
Yeah, this is where things get really interesting.
The 1960s bring us to the centerpiece of Corning's modern resurrection story, the ChemCore project, introduced in 1962. This project, intended for the automotive industry, is the absolute prime example of a costly commercial failure that later provided crucial, highly valuable intellectual property.
This is the part of the story that connects the past and the future of the company so perfectly. ChemCore was designed to create a new, toughened automobile windshield.
Right.
The goal was to make glass that was thinner, lighter, and shatter-resistant. It was designed to break into small, harmless granules when smashed, which would vastly reduce injuries compared to standard laminated glass.
So they were trying to disrupt the gigantic auto market.
A huge market. But the technology wasn't just physical tempering, it was a sophisticated chemical process. We should probably unpack that a bit.
Yeah, what was the technological innovation behind ChemCore?
The key was something called an ion exchange process, and that was paired with what Corning called its fusion process.
How does ion exchange work?
Okay, so you take a piece of specialized glass, and you immerse it in a hot bath of molten potassium salt. The smaller sodium ions in the glass migrate out, and the larger potassium ions from the bath rush in to replace them.
So you're swapping a small ion for a bigger one. Why does that matter so much?
Well, when those larger potassium ions squeeze into the space previously occupied by the smaller sodium ions, they create this immense, permanent compressive stress on the glass surface.
And glass breaks under tension, not compression.
Exactly. Glass breaks when the surface is pulled or in tension. So by putting the surface permanently under compression, you make it far, far harder to crack or scratch.
And what about the fusion process?
That was Corning's proprietary method for drawing the glass into extremely thin, flat, and pristine sheets. They invested massive capital in bespoke infrastructure for this, building special furnaces in their Christiansburg, Virginia, facility dedicated specifically to this innovative ChemCore manufacturing.
So it was a complete end-to-end investment in a radical new material and a new manufacturing technique.
Totally. They had superior technology, massive investment, and a gigantic market opportunity.
So where did the commercial failure actually happen?
The market just didn't care about superiority. It cared about cost. ChemCore was installed as side glass in some limited runs. You could find it in some 1968 Plymouth Barracudas and Dodge Darts.
Okay.
And the ChemCore windshields debuted on the 1970 AMXs and Javelins built by American Motors Corporation. But the big automakers, like GM and Ford, they had zero financial incentive to switch.
And why was that? Because there were no mandatory safety standards requiring this kind of glass yet, right?
That's the whole story. They invented a better, safer product, but if the cheaper existing product met the current regulations, the automakers just wouldn't absorb the higher cost.
So the investment was sunk.
The investment was sunk, the market refused to pay, and Corning terminated the project in 1971. It was officially labeled, both internally and externally, as one of the company's biggest and most expensive failures.
They invested in R&D, built specialized furnaces, and then walked away after losing millions and millions of dollars.
They did. But what this all means for our listener, this failure is the key to understanding the company's entire modern identity.
It really is. It's the ultimate case study in technological patience and IP synthesis.
Exactly. The unique processes, the ion exchange and the fusion techniques that were developed and perfected for this failed 1960s auto glass were later resurrected decades later.
And they became the technical foundation for two of Corning's most profitable ventures.
Their LCD display glass business, and most critically, the material science was reborn as Gorilla Glass. The failure was never in the material, only in the timing in the application.
That is the crucial takeaway. The glass on your 2024 smartphone is based on a failed 1960s attempt to upgrade a Dodge Dart.
I mean, when you put it like that,
It proves that the proprietary material science is the company's real product, not the finished consumer good.
it absolutely secured their resilience. But the 1970s also brought a second, equally monumental disruption. And this one was an immediate, overwhelming success.
The dawn of optical communications.
This truly reshaped the modern world, perhaps more than any other single invention of that era. This is the moment they stopped using copper and started using light to transmit information across the globe.
So in late 1970, four Corning researchers, and we should name them, Robert Moore, Donald Keck, Peter Schultz, and Frank Seymour, they demonstrated a monumental breakthrough.
An optical fiber with incredibly low optical attenuation.
We need to spend a moment on attenuation because that is the critical factor here. It's basically signal loss over distance. Before Corning's work, fiber optics were a theoretical curiosity, right? Unusable for telecommunications.
Completely unusable. Earlier fiber designs had extremely high signal loss. We were talking about attenuation rates that would drop the signal strength by 99% within just a few hundred meters.
So is impractical outside of a lab bench.
Totally. Corning's initial finding, which they achieved by doping silica glass with titanium, was 17 decibels per kilometer.
And why was 17 dB so revolutionary?
It was revolutionary because it proved that light could carry data over useful distances, several kilometers, which meant the technology was no longer just theoretical. It was the proof of concept that scaling was possible. The target for true telecommunication feasibility was generally considered to be 20 dB kilometers or less.
And Corning just smashed that goal on their first real attempt.
They did. And the refinement came almost immediately, which confirmed their lead.
Right.
They soon produced an even better fiber, achieving a remarkable attenuation of only 4 dB kilometers. This time, they used germanium oxide as the core dopant.
And that was the true game changer.
That was it. That 4 dB kilometer loss meant data could travel thousands of kilometers with only periodic signal boosting. It was the technical step that made transcontinental and transoceanic networking scalable.
And the impact was instantaneous and permanent.
They didn't just invent the material, they secured their position as the manufacturing leader. They invented the processes required to draw that high-purity glass into kilometers of hair-thin, perfect fiber.
And that made them the world's leading manufacturer of optical fiber.
Immediately. And they still are. They laid the foundation for the high-speed data backbone of the modern internet infrastructure.
Now, before we leave the 70s, it's worth noting that these technical triumphs were often accompanied by some internal operational struggles. We should mention the Z-Glass project from 1977.
Yeah, the Z-Glass project, which was intended for television picture tubes, it illustrates that success wasn't guaranteed just because they had the R&D prowess. It was a necessary product for the TV market at the time, but the manufacturing processes proved incredibly challenging.
Leading to high defects and internal friction.
It was considered a steep loss in profit and productivity at the time. The operational difficulties were so significant that it was later studied as a Harvard School of Business case study.
Which just underscores that Corning's history is littered with these massive internal operational challenges, even as they were innovating new materials.
Right. The 1970s truly were a defining decade. A massive automotive failure that planted the seeds for the smartphone, and a technological breakthrough that planted the seeds for the internet.
It's hard to imagine a more impactful decade for a materials company.
I really can't.
So now we move into the 1990s, where the technological necessities of the market force the company to make a hard strategic choice, abandoning their consumer identity entirely.
And then surviving a cataclysmic market crash.
That strategic pivot in 1998 is so crucial. They essentially liquidated their emotional ties to the American household kitchen. That must have been a difficult cultural shift internally.
It was a massive psychological and structural shift. Corning Inc. divested its entire consumer product line. Pyrex, Corningware, Visions, Corel, all of it.
They sold the whole division off.
The entire subsidiary to Borden, which eventually became Corel Brands. And this move was absolute. Corning Inc. ceased manufacturing or marketing consumer products entirely, focusing solely on high-margin, high-value industrial and scientific applications.
It's a classic example of a company choosing to specialize where they have a true proprietary technological edge, isn't it?
It is. Rather than competing in the increasingly low-margin, high-marketing consumer goods sector. They decided their value was in the furnace, not on the supermarket shelf.
And that strategic specialization perfectly positioned them to ride the wave of the late 90s dot-com boom.
Perfectly. Their deep focus on optical fiber meant profits soared as telecommunications companies raced to build out the high-speed network infrastructure globally. Corning expanded its fiber operations significantly, acquiring companies like Oak Industries and building several new, massive plants.
But didn't they fly a little too close to the sun during that boom? They weren't satisfied just being a component supplier, were they?
No, they absolutely stretched for more market control. They invested heavily in the photonics market components that manage light signals, with the ambitious goal of becoming the leading provider of complete end-to-end fiber optic systems.
They wanted to control more of the telecom value chain.
They wanted to integrate vertically.
Yeah.
And that's where the massive market crash hit. That ambition met reality very, very hard around the year 2000.
The collapse of the dot-com market was brutal and fast.
And because the company had overextended itself, particularly in that risky photonics venture, the failure of that market had a catastrophic impact. Telecom companies just stopped building network infrastructure overnight.
And the company faced enormous write-downs and job losses.
The stock plummeted. It went all the way down to $1 per share.
For a company that had existed for nearly 150 years with such deep community ties in upstate New York, what was the internal atmosphere like when the stock hit $1? That suggests genuine panic.
It was a true crisis. There were mass layoffs across the board, and the company faced severe scrutiny. However, despite the financial disaster and the near-death experience, the company demonstrated incredible resilience.
How did they do it?
They jettisoned the failed photonics ambition, and they doubled down on their core proprietary strength, which was manufacturing the glass itself, and returned to financial stability.
And their recovery trajectory confirms that strategy worked.
It did. By 2007, they had posted 5 straight years of improving financial performance. They successfully navigated out of the crisis by focusing exclusively on the core proprietary material science they had protected all along. The established fiber business and, crucially, their display business with LCD glass.
They emerged leaner, strategically sharper, and focused entirely on the B2B high-tech sector.
Which sets us up perfectly for the ultimate comeback story. The moment Corning found the application for its decades-old R&D that would define the next 2 decades.
The smartphone revolution.
This is the turning point that secured Corning's modern identity and justified every investment and every risk taken since the 1960s. The opportunity arose when Apple, developing the first revolutionary iPhone, approached them in the mid-2000s.
Right. Steve Jobs needed a tough, scratch-resistant display screen that could handle the wear and tear of being constantly touched and carried in a pocket. Standard plastic or cheap glass just couldn't do it.
The entire user experience hinged on the durability of that screen.
So what did Corning do?
They didn't start from scratch. They reached back into their vast intellectual property archive and resurrected the technology developed for Chemcore in the 1960s.
So Gorilla Glass, which debuted on the first iPhone in 2007, is a direct outgrowth of that failed automotive project.
A direct, perfected outgrowth. It's a high-strength, alkali aluminosilicate thin sheet glass.
So the technology that was too good and too expensive to convince Detroit 60 years ago was the only technology good enough to convince Silicon Valley.
You've got it. The durability and scratch resistance inherent in that chemically hardened, ion-exchanged glass formula proved absolutely perfect for touchscreens. It allowed Apple to launch a device that was truly revolutionary.
And it immediately established Gorilla Glass as the industry standard for portable device screens.
And the proprietary fusion process they perfected for Chemcore was adapted to create these thin, pristine sheets that were perfectly suited for modern displays.
And the partnership with Apple has only deepened since then, which really highlights Apple's reliance on Corning's specific proprietary manufacturing capabilities?
Oh, it's far from an off-the-shelf product. Apple has made significant direct investments into Corning's infrastructure. They rely on Corning's unique ability to scale this complex manufacturing.
How much have they invested?
There was an initial U.S. $200 million investment in 2017, followed by an additional U.S. $250 million in 2019, all channeled through Apple's Advanced Manufacturing Fund.
And that capital infusion helps Corning continually expand and refine the specialized production lines.
Exactly, to meet the global demand for iPhones, Apple Watches, and iPads.
Okay, so Gorilla Glass is the high-profile anchor, but let's detail the current revenue structure. Corning generated U.S. $13.1 billion in revenue based on 2024 data, and that comes from a highly diversified base of specialized industrial products. Let's start with display technologies.
Display tech is massive. Corning is the leading global manufacturer of the glass substrates needed for LCD technology. The technical requirement here is just staggering.
What's so hard about it?
They have to produce these gigantic sheets of glass that are perfectly flat, perfectly pure, and uniform across their entire surface, with no bubbles or flaws. And they proudly note this glass substrate is produced without any heavy metals.
And when you say gigantic sheets, we need to convey the scale for the listener. This isn't window pane glass.
No, not even close. We're talking about glass substrates so large that they are categorized by generations. Corning has expanded facilities in Japan, including a Gen 10 facility co-located with the Sharp Corporation complex in Sakai, Osaka.
How big is a Gen 10 glass substrate?
It's approximately 3 meters by 3 meters, about the size of a king-size bed. A single sheet of that glass can be cut into 8 or more 60-inch television screens.
And manufacturing that perfect uniformity on that scale is an immense challenge.
Immense.
Okay. Next up, the category they call specialty materials. This really shows their wide-ranging, high-end expertise, from space mirrors to semiconductor chips.
This division produces truly esoteric, mission-critical products. Look at semiconductor manufacturing. They produce high-purity fused silica, which is employed in microlithography systems.
Why is fused silica necessary for microlithography?
Well, microlithography is how chip manufacturers etch patterns onto silicon wafers using extreme ultraviolet, or EUV, light. Fused silica is necessary because it's one of the few materials that is perfectly transparent to that high-energy UV light.
So the intricate patterns can be projected accurately.
Exactly. Any slight imperfection or impurity would ruin the entire chip manufacturing process. Furthermore, it has extremely low thermal expansion, which is essential for maintaining precision during the intense heating cycles.
That links back perfectly to their historical expertise in dealing with extreme environments, doesn't it?
Absolutely. They continue to produce the low-expansion glass used to build reflective mirror blanks for next-generation telescopes.
And going all the way back to the Palomar era.
Right. They manufactured the windows for the U.S. space shuttles and famously supplied the massive glass blank for the primary mirror in the Hubble Space Telescope.
They also still produce specialized glass ceramics.
They do. Things like Vicor, which is a high-temperature glass for lab use, and Nacor, which is a machinable glass ceramic used in high-precision aerospace and medical components.
Then there's the core modern success we discussed. Optical communications. Are they still innovating and growing that segment, or is it a mature business?
It is fiercely competitive, and they have to constantly innovate. They continue manufacturing vast quantities of optical fiber and cable, with major operations based primarily in North Carolina. A key innovation that keeps them ahead is the clear curve fiber, introduced in 2007.
And what technical problem does clear curve solve for modern networking?
It uses nanostructure technology to manage the light path inside the fiber. This is critical because it facilitates small radius bending without significant signal loss.
Which you need for what they call FTTX installations.
Fiber to the home, or fiber to the business. You often have to pull fiber through tight conduits around corners and into confined residential spaces.
And standard fiber would lose signal if you bent it too tightly.
Precisely. The light would leak out of the core. ClearCurve's nanostructure acts as an internal reflector, allowing the fiber to be bent to a really small radius, sometimes as tight as 5 millimeters, without excessive attenuation.
So it makes the crucial last mile of high-speed connectivity dramatically easier and more reliable to install.
That's right.
We should also not overlook their environmental technologies division. This segment, while maybe less exciting than smartphone screens, is critical for global pollution control standards.
This division is all about emission control devices. They are a major global manufacturer of ceramic substrates for catalytic converters used in cars and light trucks with gasoline engines.
And these ceramic parts have to have massive surface areas.
Thousands of channels per square inch to facilitate the chemical reaction that reduces pollutants, all while withstanding extreme operating temperatures.
And I understand they're heavily invested in the diesel sector as well.
Yes, they're investing significantly in producing specialized ceramic emission control products for diesel engines, driven by the continually tightening global emission standards, especially in Europe and Asia.
Which requires advanced porous ceramics to filter particulate matter.
Exactly. It's an R&D race just as fierce as the one for phone screens.
And finally, a brief but important mention of life sciences.
This division applies their material science expertise to the biomedical sector. They offer products to support advanced life science research, like high-quality labware and specialized surfaces for stem cell culture products, which require extremely precise material compositions.
So to maintain leadership across these 5 cutting-edge fields, Corning hasn't slowed down on growth or investment. Let's look at their recent acquisitions.
The telecommunications segment has seen significant bolstering. They want to be an end-to-end solutions provider, moving beyond just the fiber itself.
Right. In 2011, they acquired Mobile Access Networks.
An Israeli company specializing in distributed antenna systems, or DAS, which are essential for seamless wireless coverage inside large, complex facilities like stadiums, airports, and university campuses.
That was followed by the acquisition of SpiderCloud Wireless in 2017.
And then came the largest recent expansion, which was directly aimed at market domination in the fiber sector.
The 3M deal.
That's right. Their most significant strategic move came in 2017 and 2018 with the acquisition of substantially all of 3M's communication market division.
That was a massive transaction.
A $900 million cash transaction. By acquiring 3M's expertise in connectivity and fiber hardware, Corning cemented its position not just as the manufacturer of the fiber, but as a dominant provider of the entire optical communication solution, from cable to connector.
And all of this is supported by a staggering R&D commitment. I mean, when you compare their investment to typical S&P 500 companies, they really stand out.
They absolutely do. Corning invests about 10% of their annual revenue into research and development. For a company their size, over US $13 billion in revenue, that is a massive commitment.
It's a key indicator of their long-term technology-first strategy.
For sure. And to support this relentless push for innovation, they allocated US $300 million toward further expansion of their Sullivan Park research facility, which is near their headquarters in Corning, New York.
And despite being a multinational powerhouse with facilities all over the world, they remain fiercely tied to that small upstate New York hometown.
That corporate history and cultural tie is very strong. Corning continues to maintain its world headquarters there, and management has consistently affirmed its commitment to the region.
It's also worth noting the long history of Houghton family involvement in leadership.
Right. James R. Houghton, the founder's great-great-grandson, served as chairman until 2007, maintaining that long institutional memory. And the current chairman and CEO, Wendell P. Weeks, has been with the company since 1983, representing that continuation of deep internal expertise.
So, a financially resilient, globally successful company built on proprietary technology. But proprietary control often brings modern corporate challenges, specifically regulatory scrutiny.
That is the modern tension of a dominant material science player. The most recent challenge involved regulatory scrutiny in Europe. In November 2024, the European Commission announced that Corning was under investigation for potential antitrust violations.
And what exactly is the Commission looking into?
The probe centers on the suspicion that Corning may have exclusive supply agreements with certain mobile phone manufacturers and raw glass processors.
So because Corning controls the proprietary processes,
like the fusion draw process required for high-quality, thin, chemically strengthened glass, these exclusive deals could potentially be hindering competition in the specialty glass market.
effectively preventing competitors from accessing essential raw materials or technology.
Exactly. It's an investigation into whether their technical dominance has led to market abuse.
Which balances the picture perfectly. A necessary investigation into the practices of a company that has such proprietary control over essential cutting-edge materials. Before we wrap up the commercial side, we should note the final symbolic move away from non-core operations that occurred just before the smartphone boom cemented their future.
The sale of Steuben Glassworks in 2008.
Right.
Steuben was their high-end, beautiful art glass division. It had deep historical and cultural ties, but it was losing money, about $30 million in the 5 years leading up to the sale.
So selling Steuben, just like divesting the kitchenware 10 years earlier.
Confirmed that Corning was ruthlessly prioritizing scalable, profitable industrial and scientific materials above any legacy or artistic endeavors.
It's a powerful lesson in corporate focus and ruthless efficiency.
It really is.
So let's bring this all together. After diving deep into nearly 2 centuries of innovation, crisis, and strategic pivots, what is the core thesis of Corning Incorporated's enduring success story?
I think the core thesis is defined by resilience, synthesis, and focus. Corning's success is built not just on inventing new things, but on its unparalleled ability to synthesize past research failures, the Chemcore auto glass failure being the most dramatic example, into future breakthroughs, like Gorilla Glass.
And they strategically jettisoned highly visible, nostalgic consumer markets to focus entirely on dominating the crucial, less visible industrial and communications infrastructure sectors.
They built a reputation on technological patience, understanding that the R&D payback might take 50 years, but when it hits, it completely changes the world.
And that commitment continues, as we noted, with their decision to continually expand their world-class research facilities and remain committed to their small, upstate New York hometown despite being a massive multinational corporation.
They are the invisible giant. If you use a computer screen, a high-speed internet connection, or a modern car, you are relying on Corning's material science. Their history shows that true technological dominance comes from controlling the fundamental building blocks of modern life.
Absolutely. And as we finish this deep dive, let's leave you with a final provocative thought stemming directly from the material we analyzed today about R&D cycles and resilience.
We saw how the market need for a stronger, lighter phone screen resurrected the intellectual property and unique manufacturing processes from the failed 1960s Chemcore automotive technology.
Right.
So given Corning's stated ongoing research investment in cutting-edge areas, and they explicitly mention things like green lasers, microreactors for energy production, and photovoltaics, what seemingly unrelated decades-old material science concept, maybe something they shelved in the 1980s or 1990s as too expensive or too niche, might Corning be currently poised to resurrect next to solve a critical 21st century energy or climate challenge?
It's a company built on the profound idea that no research is ever truly wasted, and that is a powerful notion to consider for the future of innovation.